Hi guys, so today we're moving on from our confidence interval for just one proportion, and we're now going to look at what it looks like to calculate a confidence interval if we're looking at the difference in two proportions. So we would call this a two-sample confidence interval. And just a reminder from last unit, when we have a sampling distribution for a difference in proportions, that center value is the difference, our actual sample difference. The standard deviation is this guy right here, so that's going to be important to us. All right, and it still is usually a normal distribution, all right, as long as n times p and n times 1 minus p are both greater than or equal to 10 for both sample percents. So it's a little bit more legwork here. Okay, our statistic in this case is that difference in our sample proportion, so p hat 1 minus p hat 2, plus or minus our z-score, that critical value, times our big square root, right? So p hat 1 minus, or 1, I'm sorry, goodness, 1 minus p hat 1 over n1 plus 1 minus p hat 2 over n2. Right, so that is what is given. Now remember, up at the top where it says P1 and P2, that's assuming we have those population percents. But remember, in this unit, we don't have those. That's the whole reason we're doing confidence intervals. So we have to use P hat. Right, now if we're using our formula sheet, that would be right here. Sorry. And remember, this is a standard error, and it's right here. Okay, so that is sort of where we could reinforce that if we need to, we can use our sample percents. Okay, so our full process remains the same. So let's go ahead and read example 1. It says, as part of the Pew Internet and American Life project, researchers conducted 2 surveys in late 2009. The first survey asked a random sample of 200 U.S. teens, so N1 equals 200, and it was a random sample about their use of social media and the internet. And a second survey posed similar questions to a random sample of, so N2, 2,253 adults. Okay, that seems like sort of a funny thing that was so much larger than the first. In these 2 studies, p hat 1, 73% of teens, and p hat 2, 47% of adults said that they use social networking sites. Use these results to construct and interpret a 95% confidence interval for the difference between the proportion of all U.S. teens and adults. So that sort of helps reinforce the order we're going here. Teens first, then adults. Now notice I've taken away the whole template that we used yesterday to fill in, and that's because you're not going to be given that. So we just have to know our steps. And so remember, step 1, we are estimating the population difference between the proportion of all U.S. teens and adults who use social networking sites, right? And we're going to do so using a 95% confidence level. Okay, so that's step 1. Define the parameter in the confidence level. Step 2, check the 3 conditions, right? So we know we had 2 random samples. Check, check. They are independent. For our first sample, 200 is less than 10% of all teens. And for our second, 2253 is less than 10% of all adults. All right, and then normal. So we could double check that one. So normal, we have to do N1 times P1 and N1 times 1 minus P1. Okay, so we get 146, which is greater than or equal to 10. And this would be 54, which is also greater than or equal to 10. Now, absolutely, the adult sample is large enough, but let's just show evidence. So 2253 times 0.47 and 2253 times 1 minus 0.47. This guy is, we're going to just bump this up to 1059, greater than or equal to 10 for sure. Oops, and so this next one would be 1194. Also absolutely greater than or equal to 10. So both are normal. Okay, now just to save me some space, I'm going to shrink a lot of that down. Okay, so now we have defined our parameter. We've checked off our conditions. Let's do our calculations. So we start with P1 minus P2, so 0.73 minus 0.47, plus or minus. Now to find that z-score, remember we're going to use our normal distribution where we've got negative z and positive z and 0.95 in the middle. And so when we go to inverse norm, we're going to put 0.95. Keep that on the center. Or if you need to, 0.025. And we get 1.96. And, well, negative and positive. Times our great big square root. So 0.73. Oh, I was missing something up here. I just realized that. When I plugged this in, we needed our p hat to go in front. Whoops. Okay, so make sure you add that to your formula. Make sure you remember where to find that. So we would do 0.73 times 1 minus 0.73 over N1 plus 0.47 times 1 minus 0.47 over N2. All right, so now I do that whole thing at one time in my calculator. So I've got my big square root, 0.73 times 1 minus 0.73 over 200 plus 0.47 times 1 minus 0.47 over 2253. And I get 0.0331. So that gets multiplied by 1.96 in order to find our margin of error. And in the meantime, I'll do 0.73 minus 0.47. So 0.26. Okay, and this was 1.96. All right, so now let's find that margin of error. So 1.96 times 0.0331 is 0.0648. And so if we subtract that, we get 0.1952. And if we add it, we get 0.3248. Okay, now again, I'm going to shrink that down. So now we interpret. And when we interpret, we will say we are 95% confident that the difference in the population proportions is between 19.52% and 32.48%. Now remember, because we already defined the fact that we're doing teens minus adults, we did that up here. We don't have to be that specific. But if you leave that step out, or if for some reason you don't do that, make sure when you interpret, you are very specific about the difference of what or between who. Okay, so one last thing to shrink down. Now let's talk about this. So if our difference is positive, let's think about what does that mean here? Well, because teens were first, that means that the teen percent is always guaranteed to be bigger than the adult percent, which we probably could have figured out based on how much larger the sample percent was for teens. But it's just good practice to know or be able to explain what this kind of large positive difference between these 2% means. Okay, so there's an example. Here we've got example 2. Researchers designed a survey to compare the proportions of children who came to school without eating breakfast in 2 low-income elementary schools. A simple random sample of 80 students. So N1 is 80. From school number 1 found that 19 had not eaten breakfast. So 19 out of 80 is our sample percent. So p hat 1 is 0.2375. And then our second percent, school number 2, they sampled 150 students and found 26. So 26 out of 150 is 0.1733. All right. Calculate a 98% confidence interval for the difference in the population proportions. What conclusions can you make from your confidence interval? So here we're going to say we are working to estimating. Okay, I didn't add that word in the past, but it's always could be good to state that you are estimating something using your interval. So estimating the difference in the proportion. Well, I guess we should say population proportion. Proportions of students who had not eaten breakfast for the, or maybe at the 2 schools. And we're going to use a 98% confidence level. Okay, so now we check off our conditions. It said an SRS, so absolutely random. Right, now yesterday I maybe detailed why it's random. To be honest with you, if you just check it off, that's helpful enough to know that you know that is one of the conditions. But if it helps, you could say SRS of 80 and 150 students. Independent. Well, this is one where we sort of are just going to assume that these are larger than or smaller than 10% of the population. So here we could say 80 is less than 10% of the population, and 150 is less than 10% of the population. Okay, excellent. So we're going to double check off our independence and then normal. Remember, to show normal, we do n times p and n times 1 minus p for both. Now, because it gives us these numbers, we already know that this will be 19. And so the difference between that and 80 would be 61. Definitely both greater than or equal to 10. And then we've got 150 times 1 minus, or no, not 0.1738. And 150 times 1 minus 0.1738 would be 26 and 124, both of which are greater than or equal to 10. Okay, so here I'm going to shrink down this to give me space. Oh gosh. Okay, so now we show our work. So we've got our 0.2375 minus 0.1738 plus or minus that critical value. So we've got a negative z and a positive z with 98% in the middle. So 1%, 0.01 on either side. When I do inverse norm, I get 0.98 or 0.01, depending on what kind of calculator you have. And so I get a critical value of 2.326, so 2.33 times our great big square root, 0.2375 times 1 minus 0.2375 over 80 plus 0.1733 times 1 minus 0.1733 over 150. Okay, so now we calculate that standard deviation. And I got 0.0567. So 0.2, well, and let's go ahead and subtract those to find our difference. So 0.2375 minus 0.1738 is 0.0637 plus or minus 2.33 times 0.0567. So that margin of error is 0.1321. Okay. So now when we subtract 0.0637 minus 0.1321 is negative 0.0684. If we add, we get 0.1958. Interesting. Okay, so now let's shrink this work down so we can interpret. Oh, goodness. Okay, so to interpret, we would say we are 98% confident that the difference in the population proportions is between negative 0.06. Oops, that's a 0. Well, and so it'd be negative 6.84% and positive 19.5%. Okay, so let's talk about this. You might be thinking, well, it's negative. It can't be negative. It absolutely can. Right? A negative difference implies that the first number is smaller than the second. So that is why probably this question was asked. What conclusion can you make? We can't really make one, right? Because in some parts of the interval, this is a negative difference, meaning school 1 has a smaller percent of students who didn't eat breakfast than school 2. And in some parts of our interval, it's positive, meaning school 1's percent is higher. And so we really can't say for sure which school is bigger because we've got both negative and positive differences. So what conclusion can we make? We cannot make a conclusion because our interval contains negative and positive values for the difference. I'm going to shrink that so you can see it. Sorry about my big handwriting. Okay, so if you think back to our first example with the adults and the teens, when it was always a positive interval, that told us that the teens will always have a higher percent that use social networking. But in this case, we've got a negative and a positive, which means we don't know which one is bigger or smaller and by how much. So we can't really make a conclusion. Okay, so go ahead and work. You've got 1, 2 practice problems to do. All right, I know it feels like a lot of steps, but remember it's the same steps over and over so that you really, really understand all of the things that go into running a full confidence interval. Okay, so I hope that was pretty easy to follow, and next time we talk, we will do the confidence intervals for means, so we'll be switching up what we're looking at.